Hey guys, we're going to finish up lesson 3.1, so I'll present my screen and we'll get started. Okay, so we're going to talk about solving by factoring. There are steps we follow to factor. The first, which I actually didn't write, the very first step is to make sure it's set equal to 0, okay? Then you're gonna look for the GCF. If there's a GCF, you pull it out and then you move on. If there's no GCF, you move on to step 2. Step 2 is to count the number of terms. If there are 2 terms, it's going to possibly be one of our factoring patterns. It doesn't have to be, but it possibly could be, which I'll go over the factoring patterns with you in a second. If there are 3 terms, like this first problem, 1, 2, 3, we're going to try to solve this by factoring guess and check, right? Reverse FOIL. If there are 4 terms, you're going to factor by grouping. Now, the patterns that I was referring to, if you remember from Algebra 1, you learned about the difference of squares. So, for example, if you have a squared minus b squared, that factors into a minus b, a plus b. Okay. Now, 2 new ones that you may not have seen before are the difference of cubes and the sum of cubes. Now, both of these factor into a binomial followed by a trinomial, binomial followed by a trinomial. And the cool thing is they factor the same way. It's going to be a, b, then a squared, then 2ab, and then b squared. All right, same thing here. A, b, then a squared, then 2ab, then b squared. The difference is the signs, all right? The signs, I don't know why that popped up. The signs are what are different. And we use a mnemonic device called SOAP, right? SOAP, to help us figure out which signs go where. SOAP stands for same, opposite, always, try that again. Always positive. All right, so what I mean by that, same sign, whatever sign is here, same sign goes in the first spot, same, then the next spot, opposite, so the opposite of a minus is a plus, and then always positive, plus. So here, all right, when you try to figure out the sign, you look to see what the original problem was, and this is same sign, so positive, opposite sign, so a negative, and then always positive, so positive. Okay, this will make more sense, and I'll go through it again with you when we do our first factoring problem that involves this pattern. All right, but that is the sum and difference of cubes. Okay, so now let's move on to our factoring problems. All right, so the first one is already set equal to 0. There is no GCF. I count the number of terms, 1, 2, 3. There are 3 terms, so I try to do reverse FOIL, guess and check. All right, you try to break it into 2 binomials. What 2 numbers multiply to a positive 36 and add to a negative 12? That would be negative 6 and negative 6. Once you're in factored form, you set each factor equal to 0. This is called the 0 product property, and you solve for x. So you get x equals 6, x equals 6. Because it's a repeated answer, right, this binomial matches this one, we call it a double root. So x is equal to 6, and you can either write next to it just dr, standing for double root, or you can actually write the words out. Maybe for the first time, I'll write the words out if my pen wants to work. All right, so it's a double root, which I said you just do d dot r, okay? All right, the next problem, let me see if I can just draw like a line and leave my work up. See if there's enough room. Okay. The next problem is not set equal to 0, so that's the first thing we're going to do. And I'm going to leave my x squared term positive, so I'm going to move the 14x over by subtracting and the 40 over by addition. So moving the 14x over by subtraction and moving the 40 over by addition, right, and set it equal to 0. Then you look for a GCF. There is none. You count the number of terms, 1, 2, 3. We factor by guess and check or reverse FOIL, okay? So I'm trying to think of two numbers that'll multiply to 40 and add to a negative 14. All right, well, if I have a 10 and a 4, and they're both negative, that'll multiply to a negative, or excuse me, multiply to a positive 40 and add to a negative 14. Then I'm going to set each factor equal to 0. This is the 0 product property. And I have x is equal to positive 10. Add the 4 to the other side. X is equal to a positive 4. So those are your two solutions, your two roots, your two zeros. Okay? All right. I think I have to erase what I have so far to give myself room for this last one. Okay, so this last one, again, I have to set it equal to 0 first. So I'm going to add x squared to both sides. Add x squared. So right now I have 6x squared plus 5x minus 1 equals 4x. Then I'm going to subtract 4x from both sides. So that'll give me 6x squared plus 1x minus 1 equals 0. There's no GCF. I count my number of terms, 1, 2, 3. There are 3 terms. So I'm going to try to factor by guess and check. This is a little more challenging because my lead coefficient isn't a 1. Okay, so you might have to try like a 6 and a 1x or a 3 and a 2x. All right, I'm going to try a 3x and a 2x. My only factors of 1 are 1 and 1. Okay, this is where it takes a little bit more time. I'm going to check my outsides. When I multiply those, that gives me a 3x. When I multiply my insides, that gives me a 2x. When I combine those, I want a positive 1 when I combine, when I add. So to get a positive 1, my 3 would have to be positive. My 2x, stop being crazy, my 2x would have to be negative. All right, so my 2x has to be negative. So that means I need a negative here, so that when I multiply, I get a negative 2x. I need a positive here, okay? And now I can, again, FOIL. Oh, goodness, I didn't mean to erase that. Sorry, guys. So what was it? It was 6x squared. Then it was 1x minus 1 equals 0. So I had a 3x and a 2x, a 1 and a 1. The 3 has to be positive. The 2 has to be negative. Okay. Now I'm going to set each equal to 0 and solve for x. Add 1 to both sides, so 3x equals 1. Divide by 3, x equals 1/3. Subtract 1 from both sides, so 2x equals negative 1. Divide both sides by 2, x equals I almost had it done. Almost had it done. X equals negative 1/2. Negative 1/2. Okay, so there's one answer, one root, one x-intercept, and there's the other. Right? Okay, I think we have just a few more to look at on the next page. It says, which equations have roots that are equivalent to the x-intercepts of the graph shown? Okay, so the x-intercepts, you can just kind of look to see where they are. 2, 3, that has an x-intercept at 4. And here I have an x-intercept at negative 1, right? So, I don't know what that was. So I have an x-intercept at 4. Try this again. I have an x-intercept at 4, and I have an x-intercept at negative 1, right? So I'm trying to figure out which of the other equations have those same x-intercepts. And there's a few ways you could do it, right? If you wanted to, you could come over to A, B, C, D, and E and try to factor all of them, right? And then see if they match the factors here. That's one option. You could FOIL this together and see if that equation is equivalent to any of the other equations. So you have options here, okay? I think it's actually faster to FOIL. So I'm going to take the given x plus 1, x minus 4, and I'm going to FOIL that. Right, that's y equals. So I have x squared minus So I have x squared minus 4x plus 1x minus 4. And that's going to be x squared minus, oh my goodness, this is so frustrating. X squared minus 3x minus 4. Okay, so I'm going to compare this to all the other equations. So the first equation, there is a GCF that I should factor out first. So the GCF is a -2, and that would leave me with x squared plus 5x plus 4 equals 0, which does not match this one here. All right, this next one, let's set it equal to 0. So bring the 4 over. I have x squared minus 3x minus 4 equals 0. Does this match this one? So if it does, that means it would have the same x-intercepts. All right, the next equation, if I was to FOIL it, right, it's not going to give me the same because the signs are different. Or if I set each of those equal to 0, this is going to have an x-intercept at +1 and -4. -4, okay, which is different. I had a +4 and a -1, so this one doesn't work. We said that one doesn't work. All right, the next one here, if you want to isolate and think about solving by square root, let's subtract the 4 from both sides. When I subtract 4 from both sides, I'm left with a -4. And if I continue to solve, don't worry, I'll erase. I know you won't be able to see, but if I continue to solve, I'm going to have the square root, oh goodness, the square root of a -4. Okay, square root plus minus square root of -4. And if you remember in Algebra 1, that was like a big no-no. You can't take a square root of a negative number, not yet at least, because we only know the real number system. Okay, so this one actually has no solution, no real solution, no real roots, no real solutions. All right, and then the last one, let's get it set equal to 0 to start. So I'm going to subtract the 18x from both sides and subtract the 24 from both sides. There is a GCF here of 6. So when I factor out the 6, I'm left with x squared minus 3x minus 4 equals 0. So notice how the inside portion, ignoring the GCF for a minute, matches this. That actually means that, yes, this is going to have their same roots as well, okay? All right, it's an equivalent equation. All right, and the last problem. So the last problem is our word problem. All right, it says a skydiver drops out of an airplane that is flying at an altitude of 4,624 feet. Use the formula h equals -16t squared plus h sub 0 to write an equation that gives the skydiver's height h in feet during free fall t seconds after the skydiver drops out of the plane. Okay, well, first thing you need to know is that h sub 0, what does that stand for? H sub 0 stands for the initial height. Oh my goodness. All right, I think for this last one, I'm just going to use my cursor or my mouse because this is not working well. So H sub 0 stands for the initial height. Oh, this is not any better. I can't write very well with this pen or with my cursor. H sub 0 stands for the initial height. Okay, so if the initial height is given, right, how high is the skydiver? If the initial height's given, the first part is just substituting that number in. So negative 16t squared plus 4,624. That's all they're looking for here. That is the equation that can be used to find the skydiver's height, okay, in this example. Then it says, is it possible for the skydiver to wait 18 seconds before pulling the parachute? Explain. Well, where would I plug that 18 in? Would I plug it in for H or T? You'd plug it in for T because it's time. So let's figure out where will the skydiver be at 18 seconds. So he jumps out of the plane and then he's going to wait 18 seconds to pull the parachute. Let's see what his height would be. Let's make sure it would be safe for him to wait that long. So I'm going to have H equals negative 16 and then 18 squared plus 4,624. Okay, so take out your calculators if you need to. You're going to square the 18, follow PEMDAS, square the 18 to get 324. Right? Then you're going to do your multiplication next. Negative 16 times... All right, let me just get rid of this little guy here. Negative 16 times 324. Oh, now it's going to be crazy. Is equal to just waiting for it to calm down. Negative 5,184 plus 4,624. Uh-oh, there's a problem. Add and I get negative 560 feet. All right, so if the skydiver waits until 18 seconds to pull his parachute cord, he's going to be at negative 560 feet. So is that a good thing or not? That would not be good. That means he would be underground. That means he would not be in good shape, right? If he waited 18 seconds. So the answer is no. He would die if he waits 18 seconds. Okay. All right. Another way of solving this problem, just as a different approach, you could think to yourself, okay, well, how many seconds does it take for him to get to the ground? Let's see if 18 seconds would be a good amount of time or not for him to wait to pull his parachute. So if I wanted to know how much time, what T is when he lands on the ground, what's H when he lands on the ground? The height is 0. So I could also, and now just random things are popping up. All right. I could also plug in 0 for the H value and solve for T. All right. So just one quick other approach and then we'll be done. Negative 16t squared plus 4,624. So if I'm solving for t, I'm going to subtract the 4,624 from both sides. Subtract 4,624 from both sides. So I have a negative 4,624 equals negative 16t squared. Then I'm going to divide both sides by negative 16. And that's going to leave me with t squared is equal to 289. And then I'm going to take the square root of both sides. And yes, technically you need to do plus minus the square root. But since time is only positive, I kind of ignore the negative solution. And I'm just going to say the time is 17. Okay, so you could also explain your answer as it takes 17 seconds to hit the ground, to land on the ground. So the parachuter can't wait 18 seconds to open his chute. All right. All right, guys. I once again apologize that my pen has a mind of its own. Still trying to figure out why. Change the batteries. I might just need to request a new one. I'm not sure. But we got through the lesson, so that's good. And I'll see you back here for the next one. Bye.